free radical additions. We've been talking about different types of additions, and this involves a free radical. You've probably heard of polymers. Poly is a prefix that means many. Polymers are large molecules that are formed from smaller repeating units, and those units are called monomers. So I've never actually been able to figure out what exactly a mer is, but a polymer has a lot of them, and a monomer only has one of them, right? So polymerization is the process of taking those monomers and converting them, connecting them to become a polymer. Polyethylene is formed by the free radical polymerization of ethylene. So this is ethylene. And what happens is, with an appropriate catalyst, we end up with polyethylene. Now this isn't really ethylene anymore, is it? That double bond is gone. But this is named polyethylene because it was made from the monomer ethylene. So polyethylene is composed of these CH2 groups just strung together. And N here tells us how many of them are strung together, and that can be several thousand. You know, polymers are huge, huge molecules. And most plastics are polymers. And the type of plastic and the characteristics that it has depends on which monomers it was formed from, and also how branched they are and how large the particles are. So just so you get an idea of what happens with these polymerization reactions, here an organic peroxide, which we haven't talked about yet, is broken into two different radicals. Well, they're the same, but two separate radicals by heat. And so one electron from this oxygen-oxygen bond goes to this oxygen, and one goes to the other oxygen, and we end up with a radical. Radicals are very, very reactive. This radical is looking for something to react with, right? So here we can have this pi bond. One of the electrons can come over here, and the oxygen will share one electron with it, and so we get a single bond between the oxygen and the carbon. But the result of that is that we get a radical on the other carbon. Well, this carbon radical can go and attack another ethylene unit, resulting in the addition of that ethylene unit to the end and the formation of a new radical. And so as it goes on, it keeps adding ethylene units to the end. Did I get those out of order? Or did I put that one in there twice? I don't know. It's just not making sense. These look the same, don't they? And this looks the same, and that looks the same. There's something strange. But you just keep going. This keeps happening, and this CH2 keeps getting added to the end. And it just goes on and on and on and on. And you cannot control exactly how many monomers get added, but you can kind of get a range of how many monomers are added. It's a chain reaction. You can get branching if the radical, which has always been at the end here, if that radical, instead of attacking one of these ethylene units, if it bends over and attacks one of the carbons on the chain, then you can form a radical in the middle of the chain, and that can attack an ethylene unit, and you can end up with branching this way, and then this branch can grow. And so you can get branched polyethylene. The amount of branching is going to affect the properties of the polyethylene, and that can be controlled by which catalyst you use and the reaction conditions. So that was a very brief introduction to polymers.